Welcome to anyone watching, it's Craig at mysimpit.co.uk and welcome to part 18 of the front dash build. In this video we'll be looking at the fuel quantity and hydraulic indicator panel. We'll be looking at a few key aspects of its design, and then we'll look at the construction of it and its integration into the front dash, and we'll finish by bringing it online and running some tests. Let's buckle up. So if we start by looking at an outline plan of the initial design and my thoughts around this, for this particular panel I'm looking to divide it into three parts for what will be the physical build. The first part will be the hydraulic system pressure gauges, and I'm looking to use two servo motors, and in terms of the range of motion needed for these, I'm looking to put in place some form of gearing on what will be a 2:1 ratio, and as I say, that will give it the range of motion needed on the pointer needle and also the speed that it will need to move at, so it's in keeping to that within the sim. The second part will be the fuel quantity gauge and the fuel quantity display. Now for the gauge I'm going to be looking to use a dual stepper, and that'll be quite interesting to utilise one of those. I've not used one of those to this point. And for the quantity display I'm going to stick with an Oled 128 by 32. In some of the previous videos in this series I did spend some time detailing a bit of a range of different ones I've looked at, and I utilise this in the UHF repeater and a different variant of it in the digital clock, and quite comfortable with using this, and I think it will give it the look and effect I'm after. And the third part will be the fuel display selector and a test button. So the display selector will simply be a rotary switch, and then just to get some form of test button, a momentary push button which has a good feeling of actuation to it. The second part of the design overview is to then consider this physically built panel and think of it from a wiring perspective. So for that wiring, the first part will be to take the hydraulic system pressure gauges and the fuel quantity display and wire those into a RS485 slave. Following that will be the wiring of the fuel quantity gauge, which is the dual stepper motor, and that will have a dedicated slave just for that. Now the slaves that I will use will be PCB based, as we can see here, and these are as I've used and shown in some of the previous videos in this series. But those slaves, once the wiring's fed into them, they will then in turn be fed into a PCB based RS485 master. And the final part of the wiring will be into a keyboard encoder, and that will be for the rotary switch and the momentary push button, which is for the fuel test button. So there are quite a few different parts to this panel. I think that the use of gearing will come in really handy, not just from the point of view of achieving the movement of the hydraulic gauges, which is more in keeping with the sim, but the learnings it will provide, which I can then apply further down the line when building more complicated panels. And also, separate to any inputs into the sim, that I typically like to achieve that via keyboard encoder. For any of the outputs, like the Oled gauges, so stepper, servos, etc., to drive as much of that as I can at this point through my PCB-based RS485 network. And that network, which I did detail a few videos earlier in this series, really just to be able to keep adding as many slaves as I can to that, just to see how that works when it is running a much greater number of panels. I'm also keen to try different kinds of component on this network, because I'm aware that some parts of the RS485 protocol are very timing sensitive, and some of the Arduino libraries aren't the best written in terms of turning off interrupts, which it can sometimes do for too long, and that can then mean that certain parts of the data are ignored or misinterpreted from that point. So the first step with the design is to go back to the original overall outline design of the fascia, which obviously we cut that previously into plywood and that's all in place, and we've started mounting some of these instruments. For this panel here, what we're interested in is a starting point of understanding the dimensions of the cutout and that the overall size of the acrylic piece for this fuel panel that will sit on top of it. And if we jump over to a photo of the produced and painted frame of the fascia, we can see this is one that we're concerned with now. So if we zoom in now and just take a closer look at this, and we can see here and begin to visualize the area within which we're going to mount this new panel into. So if we then go across to the Cad Cam Design, and I always organise that into different layers just to keep it clear which bit relates to what. And I've got the first two layers here that are to do with the front dash frame. And then whenever I put the FQHIP fuel quantity hydraulic indicator panel. So if we start by looking here at these two, which this green line here, this box represents a cutout in the actual frame in that plywood, and then we've got here these holes M3 size for mounting. And then against that we can put this black box here, which represents the piece of acrylic that we're going to be using, and then mounting holes within that acrylic which align and marry up to the front dash frame. We can then be thinking about the production of the panel, and we will then have engraved lines and text. So this is going to be CNC cut into the acrylic. We've got cutouts cut on the inside, which represent here the circular ones, the windows of the gauges. You've got a cutout here for the rotary switch and the one here for the momentary push button. And then we've got various screw holes, sort of more so in the centre of the panel, because we need to be mounting other components behind here. If we now think about the components as they may appear and sit at the front of the panel, there are two blue circles that appear. Now this one here represents the outline of what will be the knob for the fuel display selector, and this one here represents the one for the momentary push button. Now this one here, I've actually managed to source a knob from a Real Tornado panel, one that I dismantled previously, and in fact I'll just bring up a picture of that here, and you can see with this will allow me in the future to once I've tidied it up and repainted it in grey so it's in keeping with the A10, to illuminate the marker line. So what I've done at this point now to have that ready for that upgrade is this outer circle here, the one in black. This one will have a engraving toolpath run to take away all of the paint here. Now initially I'm not going to utilise the illumination of the marker because, as I say, it's a future plan to go through the Simpit and upgrade all of the knobs. But at that point I'll be able to take away any masking I've put behind here and have use of this illumination of the marker line, which will be really cool. The next part's to be thinking about the actual gauges. So if we have a look at the hydraulic gauges and the fuel quantity gauge, and if we have a zoom in on that one, you can see that there really is quite a bit of detail to that. So we're at a point now where we can go and machine this initial piece of acrylic and start assembling together the key components that we're going to use. I think that one thing that's in my mind after machining this is, in the future, any gauges that are particularly dense, to reduce the thickness of the marker lines. I think I can get away with that. I think had the marker lines have been any thicker, they would have all bled into just one. And we can also see now the extra toolpath I've run just to allow the upgrade of the knobs into the future with their marker lines. What we have here is all of the key initial parts for the panel, and what I tend to do as well is, wherever I can, rather than losing some of the material as waste, I'll always try to cut second parts as spares from it, whether that's the acrylic or MDF. Much better that than to just lose it to waste. I've cut out a number of pointers just so I've got a few different types to try. With these key parts in place, I can now take the MDF and do the usual sanding and priming of it that we can see now, and then also to start researching into and looking very carefully and running tests on all the components to be sure we're getting the best from them and they're working and behaving as they should. And in some conditions it runs fine like this, and in other conditions you could have two servos of different brands and one will have stutter and the other won't. And two servos that both have a designation of 90 in the description doesn't necessarily mean that they will both move 90 degrees in either direction. There are often times that one will have a greater range than another. And that stutter can occur when it's within its acceptable range. I think the main thing is just to spend that time with your components and get to understand them. And here we can see a very early prototype that I've put together that just lets me try and get a handle on the gearing of this, and to be thinking through, do I want to be 3D printing my gears? Do I want to use ones that are ready produced, such as some of the plastic ones you get with remote control car kits? The ratio, the gearing, and just the way I'll hold it all together. But a very early version, there's still a lot of play in the movement of it. As I progress with the gearing and get to a more refined version of it, I can now be thinking of how am I going to mount that at the rear of the panel. So we can see here the Cad Cam Design of those gauges, and the one thing that did become clear is I needed more mounting holes than I'd originally cut into the MDF. So I actually instead replaced that with a 3D printed version, which is a spacer that sits on top of the markers and suspends the clear acrylic window above it. But this one will have these extra 3 mounting holes which allow a recess screw to go in each, and that in turn will then hold a mounting bracket, and behind then we can actually suspend the servos in place. So if we just take a closer look just at these servos on their own, we take away some of these other layers, we can see here the 2 different servos that we're going to use, and they will sit within a 3D printed holder. Here's a 3D printed part that replaces a piece of MDF. This, which is effectively a spacer, will be hidden from view, so I've not used any smoothing compound, just a quick spray of paint on the front, and it's got the extra recess mounting holes. So this is the 3D printed part that is the servo holder. The servo is attached into this, and this then has the mounting holes for it to be attached to the rear of the panel. I decided to 3D print my gears, and I'm just mounting in place here the second one. So between them it acts as a 2:1 ratio, 18 teeth on the larger one to 9 teeth on the second. I think if the servo was driving anything of any real weight, I probably would have used pre-formed ones, but the teeth are strong enough for the purpose of just moving a pointer. So we can now see here one of the servos mounted in place, and all of the parts outlined for the second one, which will be assembled and put in place also. I think it was definitely worth the time that it took to learn how to produce my own 3D printed gears, and the benefit of that is in the future it allows me to make any type of gearing I may need, particularly where if I need something that's not off the shelf. So it's time to run some calibration tests. So this is the first time I've used a geared servo or any kind of gearing in the Simpit. I think that it's definitely given it the range and speed of motion needed for it to be in keeping with the sim. It was a bit of trial and error. I couldn't really see much online that really documented or showed this process, so it was really a question of just putting things together, making them work, and then correcting deficiencies. We then come back to the fuel quantity gauge, and in this case we know we're going to use a dual stepper motor. So if we look at the Cad Cam Design here, and within and behind this gauge there's not only the stepper itself, but also we said we were going to put in place an OLED. So I designed a mount which there were a number of screw holes I'd put into the centre of the gauge to enable it to hold something along these lines. Obviously working within quite tight parameters of trying to fit everything in with a great enough width to hold the OLED, but at the same time not impinging upon the shaft of the stepper as it passes through to the pointer. As regards the dual stepper, if we just have a look at the mounting bracket for that, obviously one which will hold it in exactly the right position, but also being mindful that the holder of the OLED will go immediately behind the gauge, but then this stepper, because of the footprint of it, needs to be suspended further back so that the one doesn't interfere with the other. And also the concern that this OLED mount, we don't want it to be too big because it obstructs the passage of light for the backlighting. What I've decided in this case is to suspend the stepper, the dual stepper, far enough back that that layer itself is the one which contains the LED backlighting, so therefore the stepper doesn't represent an obstruction, and then to minimise the footprint of the OLED holder. The OLED holder was quite straightforward to make. I'd previously designed an OLED holder for the UHF repeater, so this was just an adaptation of that design. If the obstruction of backlighting once this is in place is too great, there is an option of reprinting it in a white PLA, which in previous tests on other panels has shown to give a greater transmission of light, but hopefully it should be fine. So we'll have a look at that now. We've got the LED layer which ultimately will hold the stepper motor 2 in place, and we can see that the bleed through of backlighting is looking on the whole pretty good. So I can now go ahead and mount the stepper into the backlighting layer. I do plan in the future to design some PCBs that stepper motors would be soldered onto. In this case, at this point, it's just a simple arrangement of wiring where I've just soldered the wires directly onto the pins and then just labelled them up as to indicate which is for which motor. I'm running further tests at this point on the stepper motor. I've got the code all in place to control them, but it's more just making sure that they're configured and running properly. But it looks like it's all good and running as it should be, so we can now go ahead and begin to mount the pointers. The pointers I'm using here are those that were cut from my original piece of acrylic, and they do look good, to be fair, and that they mount quite easily. However, what becomes clear is that the thickness of them is simply too great, and by the time they're all sort of stacked in place, they extend beyond the height of the spacer, and I don't want the distance from the window of the gauge to the gauge to be too great, or otherwise it'll obscure the view, particularly when you're seated and you're flying. I therefore 3D print and mount some thinner profile needles. But as with all things, whilst that's great, it's now of a lower height, it does become clear that there can be some obstruction of one to another, as we can see now in a reset test. And that's not what I want. So I'll spend some time now to just ensure that the needles do not interfere with one another, both in terms of the one shaft that sits within a shaft, but then the pointers themselves at the end. We then reach a point where everything's moving as it should. And the reset test works also. So obviously whenever the Arduino is reset and the code first runs, upon initialization of that sketch, it's intentional that the pointers will run a certain range and during that range hit the backstop. So what we see now is what is intended to zero it. I start to build up the rear of the panel, and I can move down to the rotary switch and the momentary push button for the test indicator. I solder up the easy driver boards, the PCB slaves for the RS485 network, and then I can install at the rear of the panel the gauge unit that we've built for the fuel quantity. The hydraulic gauge unit's now completed, and I've also put in place a layer of backlighting. As I progress through the build, I take some time to label everything at the rear, so should I need to revisit it, do some maintenance, a potential upgrade, it's clear immediately upon looking what's wired into where. We now have the completed panel, so we'll just take a few moments to take a close look at that before we install it into the front dash frame. We'll now go ahead and install it. Sorted. So we'll now have a look at the backlighting of the overall panel. And the backlighting is effectively made up of three separate sections. You've got the hydraulic gauges, the quantity gauge, and then you've got the text at the bottom where you've got the fuel display selector. I do find that suspended LED strips do give a nice even cascade of light. And now we can start running some tests as we bring it online. In the bottom right of the screen we can see the new installed panel, and as we interact with that, if we look at the top right of the screen we can see the update in the sim. And what we'll do, if we bring up a close-up view now above the panel, and we'll impose that on the left hand side. You'll have to excuse the view of the panel being so dark. I found that the only way to focus in clearly of the display of the OLED was to alter the brightness on the camera. And speaking of which, if we now use the test button and just watch the update on the OLED, perhaps not the clearest view, but definitely running in line with the display within the sim. There was no Arduino sketch out there that I could put my hands on that seemed readily available that had the code for the update of this OLED display, and ultimately I managed to get it to work by taking previous sketches I did for the digital clock and UHF repeater and combining it with some other sketches I did find online that showed fuel quantities but for a different aircraft, and by sort of splicing together a number of sketches I managed to get it to work. So this panel is predominantly driven through the RS485 network, and on the left here I'll just impose a view of the power consumption of that network at a point where all the slaves are running that are installed so far. I'll just bring the brightness down. So as we can see, we know it's running on a 12 volt supply. In terms of the power consumption, it's showing roughly about 440 milliamps at the moment. Obviously that does vary according on what each of the panels are doing and the current that it draws to do that. In reflecting on the panel now it's complete, I think that on the whole it does run well. It's not perfect. I think that the stepper motor that I used, I did so many tests on by the end when it came time to build it into the actual panel I should have just put a brand new one in. I think the one in there now is a bit worse for wear and become a little bit noisy, so perhaps that would be an upgrade in the future to make it run a bit smoother and a bit quieter. The tornado knob that I've used for the fuel selector, I do plan to paint that at some point, paint that grey so it's in keeping with the A10, and at that point I'll be able to use a backlighting to illuminate the marker on it. I might potentially consider changing the pointers that are mounted on the shaft of the stepper, just so they're partly transparent, just like that in the actual A10. So other than these small upgrades, it's a nice welcome addition to the Simpit. It's been a lot of fun to use and a lot of good learnings. Thanks for watching.